So if I now draw the equivalent circuit, I will once again start from point A and point B. Between point A and B, there is still one resistance which we have not touched. That's your resistance of 7 ohm. So I will quickly mark this as point A and this is point B. And now between B and C, we have taken parallel combination of 3.5 and 8 ohm resistance, and that means I can show only one resistance in place of both the resistors. So what I'll do is I will start a resistance from B and let us say take it up to this point. Now this point, as you can see, is nothing but my point C. I will just keep it as it is for right now. Between A and C, we have taken 14 ohm and 5 ohm in parallel, so I can just get rid of this 14 ohm and replace 5 ohm with the parallel combination, which is 3.684. so that's going to be this particular resistance. So this is 3.684 ohms, and you can see that my point C becomes a single point, so there is no need to extend it anywhere. And now if you have understood, we have got the two resistors 3.684 and this is nothing but 2.435 ohm. Both come in series because my point C is no more connected to any other resistors. So we have got two resistors in series now, and hence I can draw the final circuit, this time in a proper rectangular shape. So this is my first resistance between points A and B of 7 ohms. And between A and B, the second resistance comes from the series combination of 3.684 plus 2.435. So this becomes 6.119 ohms. If I now define the resistance between RAB, that will be parallel combination of 7 and 6.119, and hence RAB or my RTH will be equal to, it's a parallel combination between 7 and 6.119. So this is going to be equal to 3.26 ohms. So that's my first answer for how much should be RTH for maximum power transfer. So RTH or RL, as per the notation given, should be equal to 3.26 ohm for maximum power transfer. So let's add the final answer. For maximum power transfer, RL should be equal to RTH, and that's equal to 3.26 ohms. Now this is just the first part of the question. We have to find out the maximum power also, and to find the maximum power we'll have to now calculate VTH. To calculate VTH, I will consider the same circuit once again with RL removed, but this time we'll have to bring in that 10 volt source into picture. So let us now start with step number 2. Step 1, we found RTH, and now we will find VTH. So VTH will be defined between points A and B in this particular direction, plus minus VTH. So let us find out the voltage VTH so that we can go on to find out the maximum power. So to find VTH, we will require currents through this 4 ohm, 5 ohm branch and 1 ohm, 8 ohm branch. What we are going to do now is, for time being, we will ignore these points A and B. We will just ignore VTH. We will find out how much is the current sourced by this battery, 10 volts, and how much part of it flows through the upper branch and how much flows through the lower branch. The moment I ignore points A and B for a moment, you can see that 4 ohm and 5 ohm will come in series, and 1 ohm and 8 ohm will also come in series. So my equivalent circuit will look something like this. I'm combining 4 and 5 and replacing them with a single resistor of 9 ohm. And I'm doing the same thing here also, combining 1 and 8, replacing it with 9 ohm. And this 2 ohm resistance remains as it is with the battery or the voltage source, which is equal to 10 volts. Now you can see this 9 ohm and 9 ohm, they come in parallel. So because they come in parallel, the equivalent resistance will be equal to 4.5 ohms because both are equal resistors. So 9 parallel 9 will be a half of 9, which is 4.5, and that 4.5 you can easily make out that will come in a series with this 2 ohm resistance. So my final circuit will look something like this. So this is 10 volts, this is 2 ohms, and this is 4.5 ohms. So finally, if I define the current sourced by the battery, if I call this current as Ix, then you can see that Ix is going to be equal to 10 divided by 2 ohm and 4.5 ohms will come in series, and hence this will be equal to 4.5 plus 2, that is 6.5, and therefore my source current Ix will be equal to 10 divided by 6.5, which comes out to be 1.538 amperes.